Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This is part of the Steps into Numeracy series and describes division by chunking. Division is one of the four fundamental skills of arithmetic. This guide describes a simple division method called chunking, which solves many division problems without the need for long division. Introduction. Division is probably the most difficult of the four basic numeracy skills to understand. It is also the one which causes the most concern. Many people were taught long division at school, and although it is true that long division can perform any division, it can overcomplicate many problems. Usually you can use other, more simple strategies to divide, and so not have to employ long division. One such strategy is called chunking. This works by breaking a division down into more manageable, smaller divisions called chunks. Adding the answers to each chunk provides the answer to the original problem. This guide explains how chunking works and gives advice on how to perform the simpler divisions on which it relies. Reading the study guide, Rules for Dividing Whole Numbers, will help you make the most of this guide, as it explains some of the rules which govern division of larger numbers by smaller numbers. This first part of this guide will concentrate on divisions which give a whole number result, and second part will show you how you can extend the method to help with all divisions. The connection between division and fractions. Fractions are an alternative way of representing division of one whole number by another. Take the piece of mathematics 154 divided by 7. You may be used to writing this using the division sign. 154 divided by 7, which is also the same as the fraction 154 over 7. And the latter notation is used in chunking. It is important to use a horizontal line rather than a diagonal slash when writing a fraction, as this helps you to line your fractions up neatly and reduces the chance of ambiguity in your working. Chunking takes advantage of how fractions add together. For example, the fraction which represents 154 divided by 7 can be split into smaller fractions so long as the numerators of the fractions add up to 154 and the denominator remains as 7. So 154 divided by 7 equals 140 divided by 7 plus 14 over 7, or 154 over 7 equals 70 divided by 7 plus 70 divided by 7 plus 14 divided by 7, and so on. What is happening here is that you are breaking the numerator 154 down into smaller chunks, which may help you perform the division more easily. This is how chunking works. Take the two cases above. First case, 154 divided by 7 equals 140 divided by 7 plus 14 divided by 7. You may know that 140 divided by 7 equals 20 and 14 divided by 7 equals 2. So 154 divided by 7 equals 140 divided by 7 plus 14 divided by 7. This equals 20, which is 140 divided by 7, plus 2, which is 14 over 7. And 20 plus 2 equals 22. Therefore, 154 divided by 7 is 22. Second case, 154 divided by 7 equals 70 over 7 plus 70 over 7 plus 14 over 7. If you cannot see case 1, you continue to break the numerator into smaller and smaller chunks until you can work out the answer. Here, 140 has been chunked into 70 add 70. Since 70 divided by 7 is 10 and 14 divided by 7 is 2, 154 divided by 7 equals 70 divided by 7 plus 70 divided by 7 plus 14 divided by 7, which equals 10 plus 10 plus 2, which equals 22. As before, 154 divided by 7 is 22. It does not matter how you chunk your numerator, you should always get the same answer. If you find this difficult or confusing, reading the study guide's types of fractions and adding and subtracting fractions may help. Using chunking to half numbers. As with many aspects of mathematics, you should practice new skills on relatively easy examples before moving on to more difficult cases. Although many of you may be comfortable with halving a number, it is a good place to learn chunking when you remember that halving is dividing a number by 2. To use chunking, chunk the number you are halving into units, tens, hundreds and so on. The advantage of this is that halving each of these numbers should in turn be easier. To find the answer, you add together the results of the simpler divisions. Example: what is half of 4,756? This is 4,756, which you chunk into thousands, hundreds, tens and units, divided by 2. So 4,756 divided by 2 equals 4,000 divided by 2 plus 700 divided by 2 plus 50 divided by 2 plus 6 divided by 2. You now look at the new divisions to decide if you can perform them. If not, you can chunk them further. However, halving is fairly straightforward and 4,756 divided by 2 equals 4,000 divided by 2 plus 700 divided by 2 plus 50 divided by 2 plus 6 divided by 2. 4,000 divided by 2 is 2,000. 700 divided by 2 is 350. 50 divided by 2 is 25. And 6 divided by 2 is 3. So 2,000 plus 350 plus 25 plus 3 equals 2,378, which is 4,756 divided by 2. Using arrows and lining the answers up, like in the example above, keeps your answer clear and helps you keep your place in the calculation. Example: calculate 334 divided by 2. Using chunking into hundreds, tens and units, 334 divided by 2 equals 300 divided by 2 plus 30 divided by 2 plus 4 divided by 2. 300 divided by 2 is 150. 30 divided by 2 is 15. And 4 divided by 2 is 2. So 334 divided by 2 equals 150 plus 15 plus 2, which equals 167. Chunking with other numbers. Many people have a good understanding of how to divide a number by 2, and using chunking to break numerators down until you are comfortable with the division may not be necessary. However, dividing by other numbers is not usually as intuitive. Also, breaking numbers down into units, tens, hundreds and so on does not work for division by a majority of numbers. However, chunking can still be used in conjunction with multiplication tables. If you are dividing a number by, for example, 3, you should make a note of its times table, up to 9 times, somewhere on your page. This serves as a reference for your chunking. It also helps to practice the times table by writing it down. There is a neat property of times tables involving multiplying by powers of 10, which helps you when you are chunking. For example, as 7 multiplied by 3 equals 21, if you multiply both sides of this equation by 10, you get 70 multiplied by 3 equals 210. And by 10 again to get 700 multiplied by 3 equals 2100, and so on. It follows that 21 divided by 3 equals 7, 210 divided by 3 equals 70, 2100 divided by 3 equals 700, and so on. You can write these divisions as fractions as 21 divided by 3 equals 7, 210 divided by 3 equals 70, 2100 divided by 3 equals 700, and so on. This property is very useful as, by adding zeros to the left and right hand sides of times tables, you can make numbers which can help you in your chunking. Therefore, by writing down the times table of the number you are dividing by for reference, you can chunk the number you are dividing more effectively. Example: what is 471 divided by 3? To chunk this question, you use the 3 times table on the right to find numbers which divide by 3 and add to give 471. To start, you take the biggest chunk out of 471, which you definitely know divides by 3. Add zeros to any of the 3 times table to make the biggest number you can, but which is smaller than 471. In this case, by adding 2 zeros to 3, you can make 300. By taking this chunk out of 471, you are left with 171. You now repeat the method and take the biggest chunk out of 171, which is 150. This leaves 21, which is part of your list, and so you are done. You can write it like this: 471 divided by 3 equals 300 divided by 3, with 171 left over. Now chunk 171, which is 150 over 3, with 21 left over, which you can divide by 3 to give 21 over 3. Now, 300 over 3 is 100, 150 over 3 is 50, and finally 21 over 3 is 7. So, 471 over 3 equals 100 plus 50 plus 7, which equals 157. It is useful to make a note of what you have left as you go along. Here, the 171 and 21 are shown in bubbles above the calculation. You can also check that the numerators add to the required number. Here, 300 plus 150 plus 21 equals 471. Example: what is 8,262 divided by 3? First, write your 3 times table. The biggest chunk you can take out of 8,262 is 6,000, which leaves 2,262. Then take out a chunk of 2,100 to leave 162. Then take out a chunk of 150, leaving 12, which is part of the 3 times table. You can write it like this: 8,262 divided by 3 equals 6,000 divided by 3, leaving 2,262, plus 2,100 divided by 3, leaving 162, plus 150 divided by 3, leaving 12, which can be divided by 3. So, 6,000 divided by 3 is 2,000, 2,100 divided by 3 is 700, 150 divided by 3 is 50, and 12 divided by 3 is 4. So, 8,262 divided by 3 is 2,000 plus 700 plus 50 plus 4, which equals 2,754. So, 8,262 divided by 3 equals 2,754. Check. 6,000 plus 2,100 plus 150 plus 12 equals 8,262. This method can be easily extended to division by other numbers. You make a note of the relevant times table to help you and use the chunking method as shown in the previous examples. Example: what is 1,883 divided by 7? First write your 7 times table. The biggest chunk you can take out of 1,883 is 1,400, which leaves 483. Then take out a chunk of 420 to leave 63, which is part of the 7 times table. So 1,400 divided by 7 is 200. 42 divided by 7 is 60. And 63 divided by 7 is 9. So 1,883 divided by 7 is 200 plus 60 plus 9, which equals 269. Extending the method to account for remainders. The examples so far have all had whole number answers. This is not always the case, and the answers to many division problems involved a whole number part with something left over. This is called the remainder. If you know some simple fraction to decimal conversions, you can extend the chunking method to help with questions which have a remainder. The following table gives some basic fraction to decimal conversions. 1/2 equals 0.5. 1/3 equals 0.3 recurring. 2/3 equals 0.6 recurring. 1/4 equals 0.25. 2/4 equals 1/2 equals 0.5. 3/4 equals 0.75. 1/5 equals 0.2. 2/5 equals 0.4. 3/5 equals 0.6. 4/5 equals 0.8. 1/6 equals 0.16 recurring. 2/6 equals 1/3, which equals 0.3 recurring. 3/6 equals 1/2, which equals 0.5. 4/6 equals 2/3, which equals 0.6 recurring. 5/6 equals 0.8, 3 recurring. 1/8 equals 0.125. 2/8 equals 1/4 equals 0.25. 3/8 equals 0.375. 4/8 equals 1/2 equals 0.5. 5/8 equals 0.625. 6/8 equals 3/4, which equals 0.75. 7/8 equals 0.875. 1/9 equals 0.1 recurring. 2/9 equals 0.2 recurring. 3/9 equals 1/3 equals 0.3 recurring. 4/9 equals 0.4 recurring. 5/9 equals 0.5 recurring. 6/9 equals 2/3 equals 0.6 recurring. 7/9 equals 0.7 recurring. 8/9 equals 0.8 recurring. 1/10 equals 0.1. 2/10 equals 0.2. 3/10 equals 0.3. 4/10 equals 2/5, which equals 0.4. 5/10 equals 1/2 equals 0.5. 6/10 equals 3/5 equals 0.6. 7/10 equals 0.7. 8/10 equals 4/5 equals 0.8. 9/10 equals 0.9. Note: A dot above a number means that the number is recurring, so 0.3 with a dot above the 3 equals 0.333 and so on. Example: calculate 817 divided by 4. First write your 4 times table using the chunking method. The first chunk is 800, leaving 17. Then a chunk of 16, which leaves 1 left over. So 800 divided by 4 is 200. 16 divided by 4 is 4. And where you can use the table to find that the remainder is 1/4 equals 0.25. So 817 divided by 4 equals 200 plus 4 plus 0.25, which equals 204.25. Example: calculate 3651 divided by 8. Using the chunking method, first write your 8 times table. 3651 divided by 8 equals 3200 divided by 8, with 451 left over, 400 divided by 8, with 51 left over, 48 divided by 8, with 3 left over. 3200 divided by 8 is 400. 400 divided by 8 is 50. 48 divided by 8 is 6. And 3 divided by 8 is 0.375, where you can use the table to find that the remainder is 3/8 equals 0.375. So 3651 divided by 8 equals 400 plus 50 plus 6 plus 0.375, which equals 456.375. Further guidance and information. If you have any further questions about numeracy or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.